Have you ever wanted to use streaming data from your manufacturing plant to detect problems with machines and then support your teams in collaborating to fix those issues? Well, today we're going to do just that with Palantir Foundry. We're first going to ingest the streaming data from Kafka. We're then going to build a streaming pipeline using Pipeline Builder, and then going to construct an ontology. On top of the ontology, we're going to build a low-code application using Workshop, and then we're going to build a fully custom React application using the Foundry APIs. Let's jump into it. So, by the end of this project, where will you be? Well, we'll have gone into Foundry, we'll have built this Kafka machines monitoring project. Inside here, we can see we've got a streaming data set of our metrics. So for example, for each of our different machines in the factory, we can see their current production rate and their current temperature and see when that metric was, etc. We then build an ontology out of this and build a low-code Workshop application where we can see for each of our machines how they're doing. So we can click on any machine and see kind of what sector of the factory it is in and see the performance over time. And then if there's some issue, we can then report an issue, explain what the issue is, and that gets created as a maintenance request. So something is wrong, submit that off. And then we can then manage these maintenance requests in Workshop. So we can see there's our something wrong request that we just submitted. But then also we will build a fully custom React application, which if we refresh, we'll be able to see our new maintenance request that we just submitted. And in here, the maintenance team can say their resolution. So no, there isn't. Click mark as resolved. And then if we go back to our Workshop and reload, we'll be able to see their comments back here. So in our maintenance request, something wrong, we can see now this has been closed and it's updated with the comment that we just put in. And that's powered. We'll go through writing all the code in TypeScript of how we built this, as well as all the things we do in Foundry to ingest the Kafka data, to pipeline it with Pipeline Builder, to construct the ontology in the Ontology Management app, build the Workshop application, build the actions, everything. Welcome back. We've now got a computer in front of us and we can start getting to the work. For some more context on what the problem is, we've got this factory where there's a number of sectors. So we've got sectors A, B, C, and D, and actually split into two different buildings. Maybe these are miles apart. This factory is very, very large. It takes an hour to walk all the way around it. But currently they have to patrol all the way around it, looking at the machines, inspecting each one. But recently they've gone through some digital transformation. They have bought new Internet of Things sensors that they've slapped on the machines and they're now recording maybe production rate or temperature, these kind of metrics. But we aren't doing anything with those. They're being put into a Kafka stream, but it's not being used yet. And so what we want to use is Palantir Foundry to process these metrics and build some kind of dashboard where they can automate this thing, where they can actually look at the machines remotely, as well as maybe collaborate between teams in sending out the right maintenance crews to go and fix them. So let's try doing that. So the first step we've got to do is actually get that data inside Foundry. And the way we're going to do that is using data connection. So first I'm going to log in. And I've logged in. This is Foundry, right? On the left, we see the applications. I've got data connection just here. If you don't, you can click view all and you'll be able to find data connection. And we're going to create a data connection agent. So I'm going to go to the agents tab and hit new agent. Great. It walks us through this. So maybe you don't need to watch me do it, but I'm going to do it anyways. So I'm going to just read these. So we see we probably want a Linux machine. I've already got a Linux virtual machine set up in the cloud for me. And so we need to make sure that that Linux machine is able to send data to Foundry. Again, I've made sure those firewalls are set up. Next, we'll give this a name. I'm going to call this my agent for Kafka because that's what it is. And we're also going to create a new project for our work. So I'm going to call this Kafka Machines Monitoring. And I'm going to put it in the Dev Relations internal organization. Default role of viewer is probably okay for this project. It depends what your permissions are. You probably want to check those. In this case, I'm going to allow everyone to view the data inside this project, but only I would have owner. And then we could change that maybe to a group later, or we could remove that default viewer access later. That's fine. Save and continue. And we're going to click this generate one-time use link. Copy that. I'm going to open up a terminal and I'm going to SSH into my agent. I've set up a SSH configuration so I can just hop right in like that. Next, I'm going to copy this command that I just did and I'm going to paste that in. And you see what this is doing is it's downloading a agent from the stack. We're going to wait for that to download. Generally doesn't take too long. It depends on your internet connection, but usually this takes about 20 seconds. So we're about 15 now, so hopefully not long. There we go, 18. Oh, that's pretty close. Next, I'm going to copy these commands to extract it. I'm going to slide this over here. We're going to extract the agent into a folder and then open that folder. We don't have a proxy in this case, but if you did have a proxy, you might need to configure that in the configuration as well. And then we're going to copy this command down here to start the agent. So that will start the agent on our Linux machine, and that'll get it going. I'm then going to hit continue, and hopefully in about 5 minutes time, this should go green and we should be ready to use it. Okay, I'm back. It's been a couple minutes and we've got a nice green check mark, so we're good to continue. And I say, click this get started thing. And then on this screen, we can see there's a Kafka source. Before I connect to the Kafka source, I need to actually have one. In the real world, you've probably already got one where you're going to connect to it. But just so you can follow along, in case you don't, I'm going to follow the quick start for Kafka, and you can see how that works. So I'm going to find the quick start for Kafka. And down here is the Apache Kafka quick start. What I'm going to do is download Kafka. And in this case, I'm going to put it on the same Linux virtual machine, but it could be on a different host. You'll just have to know the connection details, and you'll see those later. Good thing here. I'm going to go up and download that. You can see that's downloading. Next, we are going to extract that and open up the directory. And I'm going to use Zookeeper for this. You could use Craft. It's all kind of the same. But we're going to kick off that. And then we're also going to have another connection where we start the broker. We have to open up that file and then start the broker. There we go. I also know we're going to want to create some data, so I'm going to open a new terminal as well. So here we have to kind of create a topic and then write some events. So that we have some kind of simulated events to work with, I'm going to create a Python file using the Python Kafka library. So how am I going to do that? Well, first I'm going to install Kafka Python library. And you can see I've actually already installed it, but that would install it for you. And then I'm going to create a producer. So nano producer.py. So I'm going to open up the Nano text editor for this. Created this file, producer.py, a Python script. I've actually got it here, and I'm going to copy and paste this in. But we've got a Kafka producer that connects to our Kafka cluster. We've got this function, generate fake metrics, that generates these kind of random numbers for us, effectively, where we're going to pass in a machine ID, a temperature, production rate, and the current time. And we can see if the 9th machine is going to be off, the 23rd machine is going to be overheating, and the rest are just going to be kind of in a random healthy range or something like that. And then we're going to keep generating these metrics and then send them into that topic for the machine metrics topic. And then every 5 seconds, we're going to just keep doing that forever. So I'm going to copy and paste that in as our kind of producer. And then when we run producer, hopefully we should see, there we go. In the background, we saw it kind of creating a new topic for our machine metrics. And every 5 seconds, we'll be sending in new generated metrics. Then going back to Foundry, we can then create our Kafka source. So I'm going to go into Kafka. Again, it leads you through the process, but I'm going to show you how to do it anyways. We're going to connect via an agent, the agent that we kind of set up already. We'll call this source our machine metrics Kafka cluster. And choose a folder, which is going to be in our project. We created our Kafka machines monitoring project. We can select this and then create the source. Again, we're going to select our agent for Kafka. And you can see it says needs restart. That means it hasn't already got the kind of right libraries to talk with Kafka yet, but we can automatically push those libraries from Foundry just by selecting it right here. And then when we hit save and restart, it will have those libraries installed. For the URLs, we're just going to use localhost 9092 because we created the cluster on the same point. If it was on a different remote host, you just type in the URL for your Kafka remote cluster somewhere else. Also, in this case, we don't have any particular authentication on our cluster. We're only on this VM. It's only accessible there. But in the real world, you probably want to have some kind of username password thing. But for simplicity, we're going to skip that for now. So we've just hit save and restart. And now we're going to wait for that to restart. It generally will take a few minutes. But hopefully not too long. Then soon we'll be able to explore and see what our metrics are like. So it's a couple of minutes later, and now my page is automatically refreshed to show me all the different topics in my Kafka cluster. So in this case, we just have one topic, the machine metrics topic. So you can click into it to get a bit of a preview of what those records look like. And this is what we're kind of expecting, right? We were sending in these JSON records. We've got machine ID, temperature, production rate, and time, which is exactly what we expect. So that looks good. And we're going to go ahead and create a streaming sync. And so a streaming sync is where all the records we kind of coming in live and flowing through, which is exactly what we want. And so do we want just getting in future records, or do we want like right from the beginning? In this case, I'm going to go right from the beginning, so we get everything there. We're also going to say it's fine as a normal flow, and also putting it in the Kafka machines monitoring project in a raw folder is also works. And they've already figured out the schema for us. Excellent. So I'm going to hit create sync. And I get this pop-up saying running one sync. So I can hit open build details, and we can kind of see how that is going. And overall, we should see over time, like this kind of continuing to pull new records through as it kind of progresses through the build. Excellent. We'll open the output data set of that stream, and hopefully we should be able to see those records coming in. There we go. This is exactly what I was hoping to see, where we have all these records coming in. But you can see this isn't really ideal, right? We've got it as they've got this key field that we don't use, and all the values are just this binary kind of string. What we'd like to do is pass this. And so the way we can do that is we can use Pipeline Builder to build a pipeline. So in the next video, that's what we're going to be looking at. We're going to be taking this input data and transforming it through Pipeline Builder. Welcome back to this developer Deskside, where we look at building a streaming pipeline, connecting to Kafka, constructing an ontology, building a custom React app. We're doing all the amazing things today. In the last video, we looked at setting up a Migrate agent, connecting to a Kafka cluster, and bringing that into Foundry. Now we're going to look at how to transform that data and get it into the ontology. So I can see I've got the streaming data coming in, right, live as these records are kind of being added. What I can do here is just hit transform, and then we'll be able to build a pipeline in Pipeline Builder. And transform. I'm also going to make this a bit bigger. We don't need to see the terminals anymore. Great. We called it new pipeline. We can probably rename that later. We want to create a streaming pipeline. Exactly. So let's name this to our metrics cleaning pipeline. And so we have our machine metrics coming in. We can see kind of the values there. So we want to first transform this. We can see the value is actually a binary column. So we first want to cast that to a string, and then we're going to pass that as JSON. So we're going to say the value, we're going to cast that to a string. And then we're going to pass the JSON when it loads in a second. We can copy an example JSON, paste it in, and it's going to figure out the schema. We're going to say we need to pass the value column. That looks good. I'm going to hit apply. So we pass the JSON. It doesn't look very different because when we have Spark, it kind of formats it almost as JSON anyway, so it looks the same, but it is now parsed. To prove that, we can flatten the struct as it's kind of a recommended thing. So we're going to say we want to flatten the value column. That looks good to me. And now we have all of these. That looks good. And we can probably drop the value and key columns now, right? So I'm going to drop the value and key columns because we're not really using them. That looks good. Also, it's kind of convention in datasets in Foundry to use snake case. And so there's a handy thing here where you can normalize the column names and apply snake case to everything. So you don't have to like rename each one. That's a cool tip I learned from someone just last week, actually. That looks good. Our time, we'd prefer an actual timestamp. So we can cast our time to a timestamp. I think this is a seconds thing, but if it's wrong, we can just pop in and change that again. No, that looks right. Perfect. So that's a good kind of parsing of our metrics, and they're going to be flowing through. We can go back to our graph and see that looks right. We can call this, I don't know, cleaning. And if we wanted to, we could add an output right here. What I'm going to do now actually is going to join in another table. So we've got these machine IDs, but maybe really nice if they actually have names. So what we can do is we could pull this data from somewhere else, like we could pull it from Postgres, or maybe there's another Kafka cluster for that, or something else. I'm going to actually cheat a bit here and use our spreadsheeting tool called Fusion. And so in this, you can build custom tables just by writing them basically into a spreadsheet. So let's go and do that. So I'm going to go back to our projects and go to Kafka Machines Monitoring. And here I can create a new Fusion sheet. Takes a second to create. And then we can name this something like machines backing Fusion. And so what we're going to use this for is creating a backing data set for our machines. And so what does a machine have? Well, it might have machine ID. And we also said we were going to have like a name. Maybe we can just call that name. Maybe we can have like an install that date and the sector it was in, right? Remember when we had that kind of drawing of our factory, we had different sectors. So we might want to know where the machines are. So we can say machine ID, I think we went up to, well, we can have a look at our metrics. Yeah, we have M0 to M24. So let's do those. M0, M1, M2, M3, M4, M5, up to 24. We can fill that in. I'm going to call it machine 0, machine 1. But maybe these would be, more human-friendly names, like this is the boiler or whatever kind of machine is going on. And then install that, we can also set is a date and time. And we could say maybe this one is installed in 2020, 6:01 at 11 a.m., right? And we can have these date and times, and then this is sector A. These are all sector A, these are some sector B, etc. So I'll fill in this spreadsheet and I'll be back in a minute. So I'm back, I filled up my table, and now we can sync this to a data set. So I'm going to select my table, and I'm going to go table, new table. We can call this machines, and we're going to sync it to a data set. And give that a minute. We can actually click this little text over here and just check all the types are right. So I'm going to set that to string, timestamp, and string. I'm also just going to rename this just to remove the name because we don't actually need that. So it's just going to be machines. That looks great. The other thing we mentioned is that we were going to set up kind of maintenance requests so we could send tickets to the support team, etc. And so we can create a basic schema in Fusion here. If you watch Logan's video, linked below, you can see how to set this up in PySpark and do it kind of more properly, but you can also create it quickly in Fusion. So I'll show you how to do that here, just for kind of a bit of kind of a different way of doing it. So very similar. We might have maintenance request ID, probably have spelled that wrong, or have a title, the kind of request comment, the resolution comment, and then maybe the machine ID that it relates to, who it was created by, and the current status. And so we don't actually need to fill anything in for these columns because we're going to be adding to this table all through right back, which we'll get to when we create the ontology. But we'll set up that for now. I'm also going to add a little bit of formatting just so we have nice bold titles. And here we can create a new table. We're going to call this one, don't know what we call it, maintenance requests. I'm going to sync that to a data set as well. There you go. That's loaded now. And we'll have dataset name maintenance requests. And again, just set up the types here. It's probably more important here because it can't infer them because you don't have any data. I think these might all just be strings though. I guess they are. Yeah, maybe we also want to, we'll have a created at column as well, just so we have a bit of a change. And you can also see how to change the kind of ranges. So we're going to update that to M1 as well. Hit save, and then that's fine. And you can see it's spotted created at now, so we can add that as a timestamp and hit save again. Great. Oh, the trick I'm doing here to fill these out is if you kind of select one, you can press tab and shift tab to go back and forwards, and then just type the first letter of the kind of drop-down value, so S for string or T for timestamp, and you can change them quickly like that if you want. So that's kind of cool. Yeah. Anyways, good. So we've got our two dataset syncs set up. And we can go back to our pipeline, and now we should be able to join in the kind of machines, and we can pull in, say, the title or something like that, and build a better title. So the way we can do that back in our pipeline is we can hit add data sets from Foundry, and find that machines data set. So there it is. I'm going to add that data set. And you can see that it is built. It'll take a second to preview, but we've got kind of exactly what we were expecting. And now we're going to join it with our cleaned version. And what do we want? We want to keep the machine ID there. And we're just going to take the machine name. That looks good. I'm going to join on machine ID. Great. I'm going to hit apply, and we should get that joined. I can can go back to my graph and see what that looks like. So after the joining, this is exactly what we kind of expecting. We've got machine ID, and now we've also got machine name. What I'm going to do next is maybe make a title for this metrics object. So I'm going to create another transform, and we can concatenate some of the strings, right? So we can create a title where we don't necessarily need a separator, but we do want, say, the name, so the machine name, and we could have a kind of constant value of metrics at, and then the timestamp, right? Something like that. So the column, we actually want to cast the time column to a string, and look at that, that's clever. It gives you a little formatter. Let's try just the default. We'll call this title and see what that looks like. That's why the preview is really useful in being able to quickly see what these things look like. That's good. Machine 18 metrics at 2022. Yeah, that looks good. I think I might tweak the format just so we don't have to have nanoseconds, because we know they're only coming in every 5 seconds. So let's go for year, month, day, and then minute, 1 second. So let's give that a go and see how that looks like. Okay, that looks perfect. That's kind of exactly what we want. And we can also drop this name column now. So we're going to drop the name column. Brilliant. Done. Applying those changes. And this is going to be, I don't know, adding title. That's going to be what this transform does. And finally, we're going to add an output. So this is where it's going to save it back to a data set, where it'll be kind of updating it through streaming all the time. And we'll call this machine metrics clean. That all looks good. And now I'm going to deploy my pipeline, which is going to kind of kick off a streaming build, and then we'll start seeing the data flowing through. So I'm going to hit deploy pipeline, wait for that to load. So I hit deploy, and now I've got this pop-up, successfully deployed pipeline. I can then view that pipeline and see that kind of building through. And you can see it's already kind of started up a bunch of different things. Okay, I'm back now, and our pipeline is running. I can see this looks exactly as we expect. We've got our kind of title in there. We've got all the fields parsed. And now our next step is to get this, our machines, and also our maintenance requests into the ontology. So where we're going to do that is we're going into the Ontology Manager on the side. So again, you pop open this and view all, and then Ontology Manager if you don't already have that there. It's going to open up the Ontology Manager. I can close the other tabs we don't need anymore. And first off, we're going to build our object types. Then we're going to build some links between them. So we're going to first new object type for our machine. That looks good. We can select our machines data set. So our Kafka machines monitoring project and machines. I'm going to select that. As a title, I'm going to give the machine name, and primary key is machine ID. So primary key should be unique, but doesn't necessarily need to be human readable. And title key needs to be human readable and doesn't necessarily need to be unique. That looks good to me. Cool, we have a machine. And it's automatically pulled in our properties like install that and sector for us, which is perfect. Next, we're going to add a new object type. This one is going to be our machine metric. And here, again, we can go into our recent files, find our project. I think it might be in the raw file, even though it probably shouldn't be any more anyways. But machine metrics clean, that's the one that we just created with our pipeline. And so these will be just streaming directly into the ontology, which is going to be pretty cool. And we created a title for it, and as a primary key, we forgot to put a primary key on. In fact, our title will be unique. But what we could have done is gone back into the pipeline and concatenated the machine ID and timestamp to have a more kind of stable title. But that's going to be fine for us for now. So we created our machine metrics objects. If we want, we can also change the icon to be something like that's good enough. I'll create a third object for our maintenance requests. Maintenance request. And these are going to be backed by our maintenance request dataset. So I'm going to go back into our project, maintenance requests. Perfect. And maybe this is going to look like a wrench. Perfect. And again, title will be the title, and primary key is going to be our maintenance request ID. Going to create that. So now we've got those three objects. We're going to link these together. So our machines should link to our metrics and our maintenance requests. So I can go into one of these, like metrics, and then create a new link type over to machine. And we're going to say it links on the machine ID. So the metric should link to the machine via machine ID. And that looks all correct to me. And now we're also going to do the same for the maintenance requests. So I'm going to go into maintenance requests. I'm going to go down to this link type section and create a new link type. And we're going to link the maintenance request to the machine by the machine ID. That all looks correct. So there can be many maintenance requests on one machine. And I'm going to hit save there, I think. Let's just review all our changes. Yeah, that looks good. I think this all looks great. I'm going to hit save and hit save again. And as easy as that, we have 3 ontology objects created that we can now use across the Foundry platform. So in the next video, we're going to look at building these into a workshop where we can analyze all our performance across our different machines, see some charts, have like kind of a drill down view in our factory workshop. Welcome back to this developer Deskside, where we're building a monitoring solution for a number of IoT devices at a factory, streaming data in. In the previous videos, we set up our ontology. So we've got our machines, we've got our metrics, and we've also got our maintenance requests. And in this video, we're going to look at building a workshop so we can interrogate our machines, see how they're doing, and then raise maintenance requests as necessary. So let's start by building our workshop, and then we might come back to Ontology Manager to manage our actions. So I'm going to go over to workshop, and I'm going to create a new module. I'm going to save it in our project that we had. So in our recent files, I think it should be there, our Kafka Machines Monitoring project. And I'm going to call this, I don't know, Machine Monitor. So this is Workshop. It's a low-code application builder. And that's what we're going to be building our kind of metrics module in. This is going to be useful. So rather than having to walk around the whole factory looking at all the machines, they can just go in here and go through the machines. And we can see over time how maybe we might improve this as well. So first, what I might imagine is planning out a layout. So I'm thinking having all of my machines on the left in this kind of section bar here, and then being able to see the metrics over here on the right-hand side. So let's give those names. So we'll have, this is the machines, and maybe these are going to be the metrics. And first, we'll have an object list. So this is going to be listing out all our different objects that we could have. So effectively our machines. Required to have a object set. So let's create a new object set, and we're going to call this machines, and we should start with our machine object. And this is going to show us all of our machines. I'm going to sort them by when they're installed, just because then that will sort them kind of in increasing order, but you could add like a sort key or something like that to them. And we can just show the title. If we did want to show other things like maybe the sector or something like that, so we can quickly see which machines are in which sector, we could do that easily. But I think this is fine for now. And then we'll have a look at the metrics on the right to see kind of when we click on a machine, that will update this active object. So maybe I'm going to update this to active machine. So this is the one we've got, or selected machine. Let's do selected machine. That looks good. So when we select something, it's going to update that selected machine variable, and then we can use it over here on this side. So on this side, we'll have a metric card first. And so this is actually going to show us the machine that we've selected, some metrics about that machine, or just some properties. So we can have a look at creating a new variable based off an object property on the machine. So the selected machine, let's get, say, the name, for example. And we've got the name, so we'll have machine name. And then also add another metric for the sector. So we'll call this one the sector. And we'll create a new variable from, again, that object property where we have the selected machine and we have the sector. That looks good. And actually, we can call this selected machine sector. It's a good idea to rename these before it gets too chaotic. You can rename a lot of things in Workshop. Selected machine name, including both like the variables and the widgets. So we can rename these metric cards. I'm going to keep the metric card, or we can rename it. Machine properties. It's going to be, and you can see actually on the side when you go to this layout view, you can then spot everything, and it's easier to understand if you give these names. So this is going to be our machine list. Okay, great. So you can see the machine and the sector. If we click on a different machine, you can see it updates. That's all working kind of as we expect. Next, we'll actually want to show the metrics in terms of the temperature and production rate and those kind of things. So to do that, I think a graph is probably the right way. So what I'm going to do is add a graph, a XY chart, and we'll plot it as a line chart. That looks sensible. So we need to find the objects that we're going to plot here, and these are going to be the metrics related to the machine that we are using. So I'm going to create a new object set. We're going to start from the selected machine, right? And then we want to find all the linked metrics. And I think that should work. So this should be a selected machine metrics. That looks good. So we have 1,000 metrics for this one. That's fine. And then the property we want to actually plot on the x-axis is going to be the time. And it's defaulted to bucket it by year, but we haven't had the metrics going on for very long. So maybe we can just do something like bucket it by minute. And I think that's probably reasonable. That's good. It's showing us a count, which is not really what we're looking for. What we're looking for is maybe the average temperature for each minute or something like that. It's going to do the average temperature. There we go. And we can see that looks about right. It's kind of hovering around 40. It's going up and down a bit, but I think that's fine. So we've set up our line for temperature. That looks good. We can see kind of the average temperature over time. What we might also want to do is overlay the production rate. So we can say use multiple series, and we'll add a series for the average production rate per minute. So get production rate on there. That looks good. I don't know. It's arguable whether you want them on the same axes or you want different axes. If you wanted them on different axes, you could go back and add a separate layer. For now, for simplicity, I'll keep them on the same axes, but I think that's all right. And so now we have these two series on here. That looks good. Initially, I mean, you can hover over and see which one is which, but I think I might also add in a little legend so we can see how that looks. An inside chart, I think, is fine. But you can also see that the temperatures kind of jump around quite a lot, and these axes aren't very stable. So I might first fix the axes, and then we'll go into what do we do if we then can we can go through our machines. So rather than having to walk around our whole factory, we can just kind of jump through these. But what can we do next is the action we actually take, and we'll look at actions. So first, let's customize the y-axis. We can give it a title, or we don't really need a title on it because we've already got this kind of legend. It's just numeric units. What I'm going to do though is say the minimum and maximum are going to be hard bounds at 0 and 100. Shouldn't be going below freezing in terms of temperature or below 0 in production rate, and we're not expecting to go over 100 either. So you can see this one looks around room temperature, so it's probably just off or something. And now when we jump between them, the axes don't change in scale, which makes comparing them more easily. And 23 as well, we can see, that's running a bit hot. And again, maybe we want someone to send someone out to inspect that one. So what can we do to send someone out? Well, what we need to do is create an action, and then we can write back to our maintenance requests. So I'm going to go over to the Ontology Manager. So now I'm over in Ontology Manager. This is where we can manage and add actions. First, we actually need to add write back to the maintenance request dataset, because then we need to be able to be writing back somewhere to store these actions. So I'm going to go over to our objects and find our maintenance request. There it is. And on data sources, I'm going to add a write-back data set. So I'm going to generate this write-back data set. I'm just going to store it back in our project again. And you can see the kind of convention for write-back data sets is they're the same name as the data set plus _edited. So we have maintenance request edited. And that looks good to me. So we've got this write-back data set created. I'm going to hit save to just kind of create that write-back data set. And it'll take a minute, but that should be created soon. I can then go back over to the object overview and start creating some action types that then start creating these maintenance requests. So I'm going to create a new action type for create maintenance request. And we're going to add a new maintenance request object. And initially we need to provide a maintenance request ID, which is just going to be a brand new unique identifier. There's a few other things we could add. So we could add the current time as when it was created. And we can also add the current user as who created it. So maybe a few other things we can do here. These we can take in as inputs to our action. So we can ask the user to select a machine ID, ask the user to pass in a request comment and a title. And then the status, we're also going to set to a constant value. So we're going to say the status is now just going to be open or something. And then when we resolve it, we're going to set it to closed, something like that. And that looks good as an initial kind of thing to build. So I'm going to hit create. And we're just going to check the rules. So those are all fine. But our form, we've got a few unused things here. So I'm going to delete the unused properties that we don't need. And then drag these to how we should have it. So we probably want a title and a comment and then the machine ID. Maybe the machine ID should be first. I'm not sure. I mean, what's great about the ontology is you could just keep trying it out and show some different users, different ways of doing it, and see how that works. And in fact, rather than having to type in the machine ID, so we could do something like this, right, where you type in, which machine 23 is overheating or something. What we could do is have a drop down of all the machines, which is going to be kind of more intuitive and prevent people making mistakes. So we're going to actually swap this out to an object reference. So we want an object of type machine. So they have to select a machine. And you can see here now you can select a machine and you've got kind of a drop down, which is exactly what we want. And the title, that looks perfectly fine. We want it to be required. That all looks good. And the request comment as well. It looks good, but one of the issues is if you're typing lots of things in this comment, there's not much space. So we can actually go to display and change this to a text area. And then we get a bit more kind of space to put it in. And the user can also drag and put more context in if they need to add more. We could also add a description. So explain the issue you are seeing with the machine. And then you get a little kind of question mark, which can help users understand what the things are. I'm going to just change that name to machine, just because it is now a machine dropdown. And that all looks good. It looks like we have a working form. I think submit is fine, so we don't need to customize that. We could set up an action log. So every time someone creates a maintenance ticket, we can then create some kind of audit trail. I think we're okay for now, but we could add that later. Additionally, we can set some validation, some like kind of security criteria on who can submit this. For now, I'm just going to allow myself to submit requests, but we could change that in future. So different users could, have different privileges. Maybe there's a group of people who should be accessing this and should be submitting maintenance tickets. They can be checked for here. So that looks good. I'm going to hit save on that. I think that's all good. Actually, it's giving me a warning saying the API name is auto-generated. Given that we're going to be wanting to call some of these actions from the API, I am going to give this a nice API name where I can change it here. So this might be create maintenance request. That looks good to me. I'm going to hit save on that now. No warnings. Great. So now we've got our action. We can go back to our workshop and then use this action. Let's go back to our workshop and maybe in this header here, we'll add our button. So I'm going to get plus and add a button group. And this button is going to raise a maintenance request issue. So we can give it a little nice icon and say when we click this button, we want to create a maintenance request. That looks good. We can actually set up some of the defaults. So by default, you probably want to report an issue with this machine. So you can say the machine to use should be the selected machine. That's good. And what we could do, so here, it's going to pre-fill with machine 0. If we wanted to, we could make this disabled so they can see it's pre-filled with machine 0 and they can't change that, which is useful for preventing errors again. Or you could hide it completely, but that is up to you. That looks good. I don't think we need to do anything else there. That's all good. So now we can report an issue and say, what was our example? Our example was, I think, machine number 9. We were looking through the machines. Machine number 9 isn't producing anything. So I'm going to report not producing anything. Machine 9's production rate has been 0 for the last couple of hours. Please can you look into this? Great. I'm going to submit that off, and that creates a maintenance request. So we haven't got a particular view to see these maintenance requests, so maybe we can do that now in Workshop. So at the top here, we can have a tab for viewing our machines, and we can also have a tab for viewing the maintenance requests that we've submitted. So I'll create a tabs. That's good. So our first tab will be our machines. And then our next tab will be our maintenance requests. So what we have to do now is set up some layouts. So we're going to switch between these when we change the tabs. So we have one kind of default page layout, but we want a new page as well. And this one we might call our maintenance requests page. And maybe we'll call the other one machines page, right? Something like that. That looks good. And then we can hook this up. So our machines, when we click it, we should switch to the machines tab. And then our maintenance requests tab, when we click it, we're going to switch to the maintenance request thing. So now we can switch between these, look at that, and we can have these two different parts of our application. So now our next thing to do is actually build out this maintenance request thing. I think we'll have a similar thing where we have our maintenance requests on the left, and then we can see our maintenance request on the right. So I'll put requests, and then maybe this is one particular request. We can have a object list here, where we have a list of all of our maintenance requests. So I'm going to create a new object set, we're just going to start with our requests. Now we can see our request that we just put in, not producing anything. Maybe in this case, we might want to see a few more things, like when was it created at, and possibly the status as well. So we can see this is still open, still needs to be investigated. We could add maybe an assignee as well if you're making a real ticket workflow. You can see the other video Logan did on like a more kind of Kanban style board. We have maybe more flexibility on this. Again, we're not going super deep into that. You can see that video for that. But this is good enough for our purposes. So we can see the request. And then over here, we might want to show the selected request. So we have this object list active object. We can call this selected request. And then here, we could show maybe the object view. I'm going to keep this simple of the selected request. And now we can see the kind of various properties on the request. So other things you might want to do on our request, you might want to filter, who's created it, when was it open, the status, etc. What we could add is a very simple filter list component. So I'm going to click above to create a new widget above and pop in a filter list. For this, we're going to filter all the maintenance requests down. So we get selecting all the maintenance requests, and maybe we have a filter to search by, let's currently just do the status for now. We can also set this to display at auto height, so then we can click between these. Currently, they're all open, so the status is just open. But if there are multiple values, it would show you all of them, and you could filter down through them. So the problem is, though, is this list doesn't actually filter this object because we're using the same object set. So what we actually want to do is have our filtered maintenance requests shown here. So we're going to create a new object set for our filtered requests. We can start with all of our requests and then filter using this output from this filter kind of list here. So now when we would select our value, we could see it. So if we swap this to exclude open tickets, we then show nothing, which is kind of exactly what we're expecting. Great. So I think that's good for our maintenance request dashboard now. Well, the next problem is we can't close a request. So we want to be able to resolve a request. So now we can go back to Ontology Manager, add that action, and use that. Let's go back to Ontology Manager. And again, you can kind of do this very iteratively, where you go through and build your workshop out, and as you're building it, you can build those actions out. So back at our maintenance request object in the Ontology Manager, here we can see our create maintenance request action type. But now we want a new one, so we're going to create a new one and call it resolve maintenance request. I'm going to change our object. We want to select a maintenance request to modify, and then we're going to change the resolution comment to add that. And we're also going to change the status, I think. And the status we're going to just change back to closed. Resolution comment. I think that's all fine. So let's create that object. That looks good. I'm going to get rid of the unused parameter again. Resolve it. And as before, we can go into this parameter and change it to be a text area so that users have a bit more space to kind of type in their comments there. I think that's all good. Again, only I'm allowed to submit it, and we'll probably have to come back to change that later, but I think that's fine. We're also going to give it an API name, so we'll call this resolve maintenance request, and hit save. And save. Give that a minute to update. Hopefully we can come and use it. So actually, I'm just going to save this and give it a reload, and then we should be able to use our new action. So we've got our object here. Again, we'll probably put it in the same place just because our users would expect things to be in the same place. So we'll create a new button here, and we'll call this resolve request. And this is going to be like a issue tick. I think there's an issue tick. Yeah, that looks good. And so you can see the kind of flow that maybe some operators are reporting issues, and then maintenance teams go out on the ground. They can open this up and resolve the tickets off from there. So they're going to resolve it. And when they click it, it's going to call the resolve maintenance request action. Again, we can pre-fill in the maintenance request object with our selected maintenance request. And so that means like when you've got this maintenance request open, it'll automatically select that there. And again, for consistency, we'll set it to disabled. So when you click it, you can't then change that maintenance request. You pop in a resolution comment, and then it is closed. So that all looks good. We can test it straight away. So I'm going to try resolving it and say we looked at this and needed to turn it on. Now seems to be working correctly. Something like that. And hit submit. And you can see it takes a minute to think about that. But the status is now updated to closed. And if we look at the properties, we've got both the request and the resolution comment. Great. So there we have it. There's a simple workshop where we can see our machines, right? We can go through all our different machines, see how they're doing in terms of metrics, and then raise issues when we want to report it to the ground maintenance crew. Once they go and fix the machines, they can then resolve the tickets and explain what the problem was. This is a very simplified workflow. In reality, you might want to extend it. Maybe your maintenance tickets have more states where they get handed over between different people, or they're kind of investigating or in progress, etc., or assigning different maintenance tickets to different people. You also might want a better commenting flow. So currently, you can put in one comment when you file a ticket and one comment when you resolve it. But you could have like a series of comments, or maybe have a maintenance request comment object that you could also link to this object. There's also the possibility of adding automated alerts. So with Foundry rules, you can automatically alert when the production rate seems too low, or the temperature seems too high, or there's some combination of more complex factors where you want to look out for these things. Or going even further, you could use something like Foundry ML to spot with machine learning what issues might be happening when you're producing these things. In the next video, we'll look at extending this with a custom React app. We use the Foundry APIs so that the maintenance team can actually read and write from a completely separate application right back into Foundry. Thanks for watching, and see you there. So in our last videos, we set up the ontology. Here, we're actually going to jump straight into coding. We're going to build out a basic Express server, and then we're going to see how we can call the Foundry APIs from that server. So let's start up here. I'm going to make a directory for our server so we can later add our React app into its own folder. What we'll do is install some dependencies first. So we'll have nodemon for refreshing our server, Express for actually acting as a server, and Axios for making requests out to the Foundry APIs. So as those get installed, we can create index.js, which is going to be for our server. And we can start off by importing Express. So we can add Express. And then we can create an app, like so. Add an endpoint. So for example, we can add like an endpoint to get just at the main root of the server. And then we're going to have a request and response pair that we want to create a handler for. And for now, we're just going to send a really basic response saying, hello world. Great. So we created our hello world endpoint. And then we might want to actually listen for connections. So we can set a callback and then log that we are listening, just so we know when it's going. We also probably want to pass an import. So we could say, port 3001, for example, is what we're going to listen on. Listening on port 3001. And then if we run our server, we do npm start. What we need is a script in our package.json to do this. So how we're going to do this is adding a script block. So inside our package.json, we can open it up. We want to add scripts. And we have a start script, which is going to look like nodemon index.js. And so this is going to monitor that file for updates and run it whenever it changes. So I'll run npm start. You can see it's listening on port 3001. And if we go to 3001, we get a message back saying, hello world. Great, that's exactly what we're looking for. And so actually, if we update this thing, so we'll add some more exclamation marks, hit save and refresh, we get an updated message. So that's exactly what we're expecting. We've got our basic server up and running. So now what we'd really like to do is have our server connect to Foundry and proxy any requests through. So if we ask for the server for requests or maintenance requests, it will get them from Foundry and deliver them to us. And similarly, if we tell it to resolve a request, it can then apply the right action on the Foundry side. And the reason we do this through a proxy server, you could just hit it directly, depending on the cause configuration, specifically on your Palantir Foundry instance. But the reason we're going to do this through a proxy is you imagine there might be some extra authentication that they need to do, or it already integrates into an existing API, and we're going to show you how to do that today. So what we need to do now is actually connect this to Foundry. And the right way to do that is creating an OAuth application, which can then act as the authentication and our authorization to call the right resources. So we'll do that now. Again, all of this and more is available in the documentation. You can have a look at the documentation. The developer documentation tells you how to set up OAuth, tells you how to call the APIs, but I'll show you how to do that now. So I'm going to go down to my account and then settings. And then third-party applications. I'm actually going to make this a bit bigger just to give us some more space. And we'll create a new application. So register a new application, and we might call this maintenance app. And for now, we're just going to say this is a server application, so we've got a confidential client. That's good. We've got a client ID and client secret. We'll copy those down so we remember those. So we'll say our client ID is that, and our client secret, it's misspelled a bit, but that's okay, is that. You can regenerate these, but when you do, the previous ones will be invalidated. So you want to remember those. Good. So this is our new OAuth application. If we scroll down, we can actually see there's some authorization grant types. Currently, it's defaulting to the authorization code grant, which is when you can act on behalf of your users. So if the maintenance team had Foundry accounts, they could sign in through Foundry effectively, and then you could call the APIs on their behalf. What we're going to do now, though, actually is set up client credentials grant. This one is a bit simpler in terms of implementing it, and maybe is useful if you're already doing the authentication on your side, but it basically gives you a privilege token specifically for the application. So we're going to disable the authorization code grant and enable the client credentials one. Good, and so you can see we have a service user added that then has the permissions associated with them. That's good. So I'm going to hit save on that. And also what we're going to have to do is going to have to enable this application. So I can hit actions, enable application, and for now we're going to just enable it with unrestricted access. If you wanted to, you could lock that down to a more specific subset of who has access. That looks good. There's probably a few things we need to do now. So in our Ontology Manager, we're going to have to give permissions for the maintenance app to call those actions. So in our actions, when we want to resolve a maintenance request, we want the application to do that. So we can go to the security and submission criteria. Currently, only I can submit the action. We want to change that. So rather than looking at the user, we can change that to from me to that new service user we created called maintenance app. That looks good. If you wanted to, you could change this to a group, or you could add some logical operators, or you could have ands and ors to configure this more carefully. But I think that's all good for now. So I'm going to hit save. And that should be good. We should now be able to call this from the API. So how might we then do that? So again, I'm going to look at the documentation myself, actually. And so I can go over to the documentation, scroll down to Are You a Developer, and then view the API docs. That's what we want to see. And there are a few different endpoints. Most relevant is probably going to be listing the objects. That's what we want to do first. So we want to list all the maintenance requests so we can display them in our application. And then we want to apply the action to resolve them once they are resolved. And so this page is the documentation for this endpoint. You can see how to call it. You make a GET request to this thing. It explains what the different parameters are that you can pass in, as well as the response that you can expect to get back. So going back to our application, what we need to do is create a new endpoint where we can get the requests from. And then under the hood, what that does is it runs the client credentials grant flow to get a token for Foundry, and then calls Foundry to list the objects. So let's jump into that. First off, I'm going to create a new endpoint. So when they get the requests endpoint, we're going to respond with the requests. So we have a request and a response. And so there are two things. First, use the client credentials to get an access token for Foundry. And then secondly, we're going to list the maintenance request objects. And third, we're going to return these to the client. So how do we actually implement these steps? Well, we're going to have to make requests out to Foundry. So we're going to have to import that Axios library we installed earlier. So I'm going to require Axios. And again, you can use your own request making library here. I'm just using Axios as an example. I'm also going to paste in some sample code, which is going to hit the right endpoints. So here we have axios.request. We're sending a post request to our stack, which is dev.relations.internal.palantirfoundry.com/multipass API OAuth2 token. So this is the OAuth2 token endpoint. And we're going to be passing in some parameters alongside that as well. So we want a grant type of client credentials. As we said, we're going to use the client credentials flow to get an access token. And we're going to pass in our client ID and client secret. Remember, we wrote these down earlier when we created our application. So I'm just going to pop those back at the top and store them here. So our client ID. And so the client ID itself isn't secret and it's fine to kind of store around the place. The client secret should be kept secret. So you wouldn't want to hard code it in like this. What this should be done is this should be put in some kind of secrets management solution like AWS parameter store or HashiCorp Vault or something like that and gotten out of that at runtime securely. But for now, I'm going to leave it there. The other thing we'll notice is in this code snippet, we use this await keyword, which is for doing async things like network requests in JavaScript. To fix the error here, I'm going to put an async in front of this body, so all this runs asynchronously. Great, so we've got our access token that we can now use to make requests to Foundry. How do we actually make the request? Good question. So in this case, we're going to hit this list objects API. So we can probably do that ourselves pretty easily. So I'm going to largely just copy this same request, and this is going to be our objects response. In this case, it's a GET request to the same base URL, but to the API v1. Copy this in. To get the ontologies, and you notice there's an ontology read parameter and a object type parameter. And you can actually see the explanations for what these parameters are here. So we need to fill those in. So I'm going to use a template string to pop those in. An ontology read we'll have to define as object type. So ontology read and object type. And the way we can find these is if we go back to Foundry, inside our ontology, we can go to advanced, and down here we get the ontology read. So this is the resource identifier. So I've copied that ontology read. You can see it's ri.ontology.main.ontology. So this like final ontology tells you it is a ontology read, and then it's the ID there. And then the object type ID, if we go to the object, so this was request. So really this is not really the object type ID, this is the API name. So the maintenance request is getting a bit tight here. But it's this API name here. So I can just copy that there and pop that in. So that should be everything we need. We're now able to make objects requests, and we also want to get out the objects from that response. So we can do objects response dot data dot, I think data again, because it returns a object with a key data according to the API, right? Back here. The response body has data, which is a list of our ontology objects. So we actually want to return that. So that's what we're going to return to the client by doing res.send and sending that data back to the client. You might want to do some more validation. I would assume you'd have some kind of like authentication first, and then maybe some more validation here that this is the right kind of data that you should have access to, etc. So if we go back to our server and we try /requests, it did not work. Because we were missing credentials, right? Because we actually got our access token, but then didn't use it. So inside our objects response, we're going to want to provide, so we can get rid of our parameters, we need to provide our headers, right? So our headers, we're going to have as authorization, and the value should be bearer, and then the access token we got. So we refresh now, it works, look at that. And now you can actually see our object here. So it's a bit hard to see because it's just JSON. I can zoom in a bit. But you can see this is our request ID. This is the request comment. We can see the thing we wrote earlier. Machine 9's production rate has been 0 for the last couple of hours. Please can you look into that? So if you watched the last video when we were building the workshop, you can see that is the ticket we wrote then. Great. So now we have these objects. We're able to get them from the Foundry API. We can return them from our own server API. What we want to do is then be able to resolve them from the API. And so for that, we need to actually apply the action we created earlier. So let's jump into that. Going back to the API reference, what we now want to do is apply an action. And so we can actually probably copy and paste a lot of this. But I'm going to first extract this getting authentication token into its own function so we can tidy up the code a bit. So we can have access token is await get access token. That's good. And we'll create a helper function up here. Get access token is going to be an async function that just runs this thing and returns our access token for us. And that's going to help us reduce the code duplication a little. Otherwise, we can have maybe say, I'm going to keep this as a GET request for now, just so we can kind of test it out. And then we'll change this maybe to a post request, which might be more sensible. So we'll call this resolve request. And then we've got the access token. And then we have the same ontology read and action object type. But actually, we don't want this to be an object type. We want this to be an action type. And then we're going to copy this URL as well. Let's try that. action type and the ontology grid. And this is a post request we can see over here. So we're going to post, we want the same access token set up, and action type. Action type wasn't maintenance request though, it was resolve maintenance request. So we can get just the same API thing here, which is called resolve maintenance request. I think we set that in a previous video as well. That's good. And in this one, we actually need to send the request for how we're going to apply it. So for example, what are the values in the form? So for that, we can send in it's called body or data, I think. It's called data. I'm going to send in some data, and the data should be a map of parameters. So our parameters should look like a map of parameter ID to parameter value. So the parameter ID might be, if we go over to the form, I'm going to make this slightly bigger. The maintenance request is going to be a parameter. We can go to if you go to details, you can see the ID here. And so the maintenance request should be some kind of ID. I think I'm going to copy this maintenance request ID for now, and then in future we can pull that out in the into an actual parameter. It's the first one, and resolution comment as well. There's the ID. We can copy that there, like so. And the resolution comment we can update to I was updated in the API. Great. That looks good. And so we can send the response back from when we make the change. We can maybe see down here what the response should look like. So it's just empty object. Not so interesting. So I think we'll just say message success, something like that. Return message to the client. So now if we try and run this, where we do resolve request, we can see we've got back a success response. And if we refresh our requests API, we can see the resolution comment was, I was updated in the API. And in fact, if we go all the way back to Foundry in our workshop that we built previously, we can go over to the machine monitoring application, and we can see our request. And here we can see our resolution comment, I was updated in the API. So everything is all updated from making that one API request. Great. I'm going to take a little break here, and then next we'll build a React application that's going to hit our new server and be able to manage these requests. So before I took a little break, we'd got our server set up. There's probably a few things I want to tidy up about our server, and then we can start using these endpoints in our React app. So easy thing is just remove this unused variable. The other thing is that we've hard-coded this request ID in here. So what we want to do is actually take this in as a parameter. So we can do request.query and then the request ID. And that way we can pass in a request ID when making calls to this endpoint. So we're taking in as part of the request. So I think if we start up the server now, whoops, I need to go into the server and start it up. We're listening. So just check this one works. I'm going to refresh that. Yep, that works. We can also do resolve request. And now we need to pass in a request ID. And if we pass in the same request ID that we had earlier, we can just check that works. That's success. So for example, if we added some more exclamation marks to I was updated in the API and tried that again, and we updated the request, when we refresh here, we can see the exclamation marks are added. So that is all working as we expect. So I can create a new project, new React app with create React app. So let's try doing that. Open a new terminal for this one, and we can do npx create React app and call it web. And we can actually use the TypeScript template just to give us a bit more type safety. I appreciate it's a bit of a weird mix that we've used, just plain JavaScript on the back end and TypeScript on the front end. But hey, get a bit more variety and a bit more excitement. Obviously, you could use whatever language you wanted, both on the front and back. But this is what we're going with. So that'll take a few minutes to install. When that's all done, I'll be back with you. Okay, here we go. It's now completed running the script. It's set up our web folder, and now we have a React app in here. Very quickly, we can go inside of it and run npm start, and that will automatically open it up in our browser, and we get to see our little website. So I'm going to open up app.tsx so we can start to make changes, and we should be able to see them appear on the left-hand side. Make this a little bit smaller, give us more room for coding. So you can see edit src app.tsx and save to reload. So you can say, I'll update this to hello world. And you can see that update pretty much instantly. So we're going to use the Axios library, the same one we used on the back end to call Foundry APIs. We're going to use on the front end to call our API. So let's try installing that. I'm going to stop the application for a second and install Axios. And give that 1 minute. Once it's ready, we know what it will look like. We can import Axios from Axios. And in our application, we're going to use React hooks to store whether we've made the call or not. You might want to use a state like Redux or Zustand or something like that. If you're really doing this, I'm going to run from start again, just so we can kind of see our changes live and so we can make sure we're not breaking the application straight away. So it still says hello world. That's good. Now let's try and make a request to get our requests. That's a bit tricky. But we'll say this is going to be our maintenance requests. We're going to use state. We're going to start with just a empty array for now. And then we'll use an effect, which is just going to run once when we call our function. What this is going to do is it's going to use Axios. And we're going to make a request. And the config is going to be our base URL. It's going to be our endpoint, which is at localhost 3001. Our URL was /requests. And the method was get, right? And so that's going to be simulating as we ran requests here. And it should be able to get this list of things. So then after we've made that request, we're going to have some response. And the response data should be that array. And so we'll store maintenance requests. Should be maintenance requests, set maintenance requests, because it's a hook. And we'll set the data there. For now, we'll just like put them out as a string. I think we might have some issues, but we'll see. Give that a refresh. Okay, we have an empty array. I suspect there might be a cause issue here, but let's see if I'm correct. Access error. Unsupported protocol localhost. We just forgot to put that it should be using HTTP. Well, now we're getting a network error. So now if you look at the network, yes, it has a cause failure. So the issue here is we're hitting cross-origin resource sharing issues. And this is because we don't want to be able to hit random APIs from our website. We want to kind of limit which ones we actually hit, and also have the APIs limit where they can be hit from. So it's harder for an attacker to take advantage of a cookie or something like that placed on a user's browser and maliciously use it against the user. But in this case, we're not using cookie authentication. We might be, but in this case, we're going to say we're not, and we can just quickly install a cause package, which is going to allow us to get around this restriction. So we're going to go into our server, install the cause package, and import that here. So we can say cause is require cause, and then we can use it in our app. So app.use cause. There we go. If I hit save, we refresh here, we can see in our React application, we've now got our objects, right? We've got this kind of JSON list of things, which looks right. And so we've got our maintenance requests, and now let's display them in a table. So here, I'm going to remove this image. I'm going to strip a lot of this out. It's probably going to look kind of ugly, but it should suit our purposes. So we'll call this the maintenance app. And let's say we'll just have a list. So we'll have our order list, and where the maintenance requests, we're going to map each request into a list item. So the list item is going to have the request. Let's get the properties, and then is there a title? I think we had a title, right? Yeah, a title. Which is good. It doesn't know what the request is yet, so we're going to have to define a type for it. So we'll say this is a maintenance request, an array of those. And we can define the type here. So we can say it's interface maintenance request, which has a rid as a string, and then properties. And the properties look like this. So we have Maintenance request ID is a string. Request comment is a string. Resolution comment is a string. Oops. Resolution comment is a string. Created at is also a string. Machine ID is a string. Title is a string, and then created by is also a string. And then status is either open, or closed. That looks good to me. And so now we've got our request here. We can actually get rid of this one. We can say, oh, it's not producing anything. Was our request. And so we can see our request in our React app. We've done displaying them. Maybe we want to tidy this up a bit, fix the CSS. I'm not going to make it look beautiful here, but I'm going to remove some of the things that we don't need. I don't think we need any of that. And we'll also remove, we kind of removed everything here. Yeah, that's right. So we have a maintenance app, and in here, what's that massive margin on top of that? 0.20. There we go. Maintenance app, and we have not producing anything, and then maybe underneath we'll have the request comment. So the request properties, and then the request comment, and maybe also we'll have the status as well in brackets or something. So we have request properties status, something like that. Or we can see something like that. Yeah, that's good. Again, you could spend a lot of more time making this look like nice, but I think this is okay for our purposes. Great. I'm going to pause there. I'm going to start again in a second, take a little break, and we'll have some buttons that we can then click, and that will call back to the Foundry APIs to update our requests. See you in the next one. So I'm back with a new camera battery, and we're good to continue. So we've got this list item element here where we're displaying the request. What we'd like to do is add maybe like a input and a button so that they can type back their response and then hit submit to kind of close that off. So first what I'm going to do is I'm going to extract this out to its own component. So we're going to call this, I don't know, request view, something like that. And we're going to pass in the request. And we can actually create that now. Request view is going to be a function component where it takes in a request, and we can define the type of that as having a maintenance request property. Looks something like that. And then we can just return the same thing that we had before, maybe in a paragraph tag. And let's hit save, and we can see that is working as we're expecting. Just checking that it's working. We can add some exclamation marks. Great. Looks like it does. So that is all happy. Now what we'll probably want to do is add a input here. So we can add an input and a button. And the button's going to say mark as resolved. We can wrap this all in a fragment like that. That looks good. So now we can type something back and mark that ticket as resolved. Maybe we want to hide this if the status is already closed. For now, I'm just going to leave this like this, and we can change it around if we wanted to. And what we'll need to do is control this input, or at least be able to get some of the value out of this input. So we can either pass in a reference and then pull the value out, or we can store the kind of value in state. And I'm going to go for the second. You could also maybe use something like React Hook Form, or a FormMake or a library like that to help you manage your form state. So let's do resolution. We're going to call it resolution comment and set resolution comment is going to be use state, and that we're expecting it to be a string. So that's fine. And then the input value is going to be that. And then when we change the value in our input, we want to then update the value in our state. So we're going to have the event, and then we can set the resolution comment to whatever the event target value, which is going to be the value in the field. So the event target is the input, and the value is going to be the value that it's just updated to. So we can see we can now still type things in, and it will now be stored in this resolution comment field for us. And then when we click the mark as resolved button, we want to hit our API. So I'll just say on click, we can call update request, and I'm going to find that function here. So update request, it's not going to take any arguments, but it's going to send this updated maintenance request. So let's go back to our server API, and we can see what we did there. So we had this resolve request. We can probably change this to be a post. That's probably more accurate. Resolve request endpoint, where we were going to pass in the request ID as a query parameter. And we also need to actually pass in the resolution comment as well, I've realized. So let's do query resolution comment. That's good. We could also pass it in as like a body, but I think that is fine. So here, what we want to do is make a request. And again, we can probably copy this stuff here. Whoops. This stuff here, but in this case, it's going to be a post request, and we're going to do to the URL resolve request, and as parameters, we want to add that the request ID is going to be the request properties in this request ID, and then the resolution comment is going to be our resolution comment that we've just been typing into this text box. So now let's give that a test. So we've got our field here. We can type things in. We can click mark as resolved. And hopefully that should have sent a API request to Foundry. So actually we'll send it again. And we can see we've sent this resolve request and we're getting a 200 back, which suggests it's happy. And so if we go back to our workshop, just as an example of where you might see the object and check that it's been updated, we can see this property should have been updated to ASK DLFJ, whatever I typed in here. And so we can see we're writing back. We could also actually show the resolution comment in this as well. So maybe we could do request properties resolution comment. The only issue is this won't update immediately because we'll actually want to be updating the requests in some way. We could want to like rerun this use effect code. That's basically the end of it. Appreciate this is a very simple application. We can do a bit of testing if we want and just try things out. So for example, if I went back to my machine's workshop and then I said, I want to report an issue on machine number 5, say, please look into this, and then left some kind of helpful comment, right? And then submitted that. We'd see that was applied here. And if we refresh our React application, and again, you can change this to be auto-refreshing, we can see that application, that comment comes in through here. We can see we've said something here, and we can also mark it as resolved back in here. So we can say, looked into it. Great. Mark is resolved. And I can actually manually refresh this, and you can see that it's been marked as closed, and I've added the comment, looked into it. But then also if I go over to my maintenance requests and see my please look into it, I can see that it's been closed with the resolution comment, I looked into it. So it looks like it all works, right? All those updates seem to be passing through, and I'm pretty happy with that. And I think that concludes our Foundry developer desk side for today. Just as a recap of what we did is we set up a Kafka cluster, and then we started streaming the data into Foundry. We then transformed that data using Pipeline Builder. We then constructed an ontology of machines, maintenance requests, and machine metrics. And we then built a low-code application in Workshop using those, where we could go in, monitor the machines, see how they're doing. We could then use actions to raise maintenance requests, as well as built a tab in Workshop where we could manage those maintenance requests. And then outside of Foundry, we use the Foundry APIs to build a fully custom React application where we can manage the same data in a different application. Thanks for joining me today. We'd love your feedback on whether you enjoyed this long-form content, whether you enjoyed this kind of custom development, seeing how the APIs integrate. And also, we'd love to hear what you're building on Foundry. So please do comment below, and we'll see you around.